The President of the Aseanian Membrane Society, Yang Berusaha Profesor Teknologi Dr. Ali bin Selamat, Alhamdulillah, selamat kita. Our Deputy Vice Chancellor, student, Professor
Science and Technology. So we are honored to welcome more than 500 participants to the AMS15, including over 300 international graduates from 29 countries. So,
Asia Pacific region. AMS15 continues this tradition, serving as a space where esteemed scholars, researchers, and professionals convene to share, challenge, and refine groundbreaking ideas. This year, we are proud to have AMS15 organized by Universiti Teknologi Malaysia.
And then the sort of outline of my talk. So basically, I'm going to talk to you about ion conducting membranes for the energy related, especially fuel cells and electrolysis. So I'm focused on the fuel. So in terms of energy application, so if you look at the fuel cells or electrolyzer, right, there are different types of fuel cells or electrolyzer. So based on the operating temperature, right? So what we know is, top membranes, for fuel cells, the operating temperature, normally below 200 degrees Celsius, right? So of course, there are a few polymers that can do, beyond that, The reason we combine two nanosheets together, different type of nanosheets together, because for the fuel cell application or electrolysis, electrolyzer, so graphene is not good. Graphene has a less affinity with the carboxylic acid group, and then the diamond has stronger affinity. So that.
And the thickness is simply the fraction of nanometer. Therefore, it is very, very thin. I don't go into the detail of this equation, but when you go to the seashore next time, you will see this vast amount of saline water, seawater in the ocean, and you imagine the surface is covered by very thin layer of pure water. And in those nodules, there are spaces, and we call them aggregate water. So there are two porosities. One is network water, and the other one is aggregate water. In Singapore, Trihara and other doctors, they presented this TEM image. This is a TEM image of thin film composite membrane, polyamide membrane. You know that the surface is not smooth. Another thing is, as I said, hydrostatic pressure is constant across the membrane. But actually it is not true. This is what this group says. Okay, what are they doing?
We have a COP30 in Amazon. Yeah. So I hope there is a big announcement for solving the global warming this year from the COP30. So actually, the source of the greenhouse gases, usually the most one is prefabrication and pilot scale test by the membrane company. So fortunately, I don't have my own company, but I have a strong PK as a Taiwan. Finally found how to fabricate the porous membrane with these materials. They showed very good hydrogen production performance compared to the gel.
So all still suffers from some limitations. The internal heat loss through the membrane associated to the heat mass, heat transfer by conduction through the membrane. It's considered heat loss in this case. Increase liquid inhibition of water. I have to say here that one of the limitations of the nanofibrous membranes is that the liquid inhibition of water is still smaller than that of large sheet membranes. So we have to increase further the liquid inhibition. And finally, I don't want to see so much. These are the next step for to design, my opinion, membrane installation to improve the liquid inhibition of water further for nanofibrous membranes and use other polymers, other solvents for.
Nanofiltration, maybe also reverse osmosis membranes, which has the capability to remove salt, maybe also as active member from water, but also address the emerging concern of organic micropollutants. I think we are all aware that for that purpose there is a range of very well established fluorinated polymer featuring sulfonic acid groups, and then in the second step, this is brought in contact with the polycation. So conditions, alkaline conditions for sodium hypochlorite, where the polyamide membrane is very quickly degraded. We see that these membranes are very stable in terms.
Is the highly conductive AM membrane, because the anion exchange membrane for electrolysis, when we use the high alkaline solution, because the membrane durability and stability issue. So we the scientists for the membrane and the energies and also the mechanical engineering group together.
zero thickness, mathematical zero thickness pipe that has only one pore of a diameter d. And he considered how the water or liquid permeates by pressure force. And this is the results. And
from the center distributor. So you can see the strong air jet flow from the center distributor pipe. So the membrane can strongly creep.
Make it to love you.